Okay, so we're going to talk about molecular effusion and diffusion. And we know from previous slides that gas particles are always moving, and their speed depends on the mass of the particles. And so, on average, lighter gases move faster than heavier gases. They have the same average kinetic energy, so they need higher velocity to make up for less mass, so they move faster. When we're talking about massive gases, think about atomic mass. So when we think about a periodic table, we work with atomic masses when we're finding molar mass of things. So the lighter gases, so ones with lower atomic numbers, are the ones that are going to move faster than those heavier gases. And again, it's just showing us our kinetic energy formula again down here, just without the E for Ke. Okay, so here is, oops, I'm going to go back. Sorry about that. Here is a graph that's on your notes. You can see these different gases. So we have hydrogen and helium. These are faster gases. You can see their speeds here. They're the lighter gases. They're at the top of the periodic table. Then things like oxygen and nitrogen and water, which are slower. They're more massive gases. When we're talking about water here, we're talking about water vapor. Okay. Next, we're going to talk about Graham's law of effusion. Effusion is the escape of a gas through a tiny hole. And object that you're probably familiar with that uses effusion is a balloon. If you go to the store and you buy a latex, or sometimes we call them rubber balloons, and you get it inflated with helium, you'll notice that after about a day, it'll deflate a lot. And this is due to effusion. So what that means is on the sides of the balloon, there's little pores or holes. And so some of that helium is able to leave through those holes, and it causes the balloon to look deflated. Diffusion is the spread of gas through space. So we're going to watch a video on bromine to answer some questions. We want to know, why does this gas diffuse, and why does it take more time than you would expect? And so I'm going to see if I can get the video to play here. Okay, so this is the diffusion of bromine vapor. So this little tube here is going to put some bromine down at the bottom. And you can see it kind of clouding the bottom of our container. We're at about 8 seconds, 12 seconds, and you can see it slowly traveling up our tube. My video froze a little bit here. But if we were to watch this over time, okay, you can see it slowly climbing up. And after about 2.5 minutes, it's about 2/3 of the way up our tube. So I'm going to go back to our PowerPoint here. So why does the gas diffuse? Okay, the gas diffuses because it wants to take up all the space in that container. Okay, it wants to spread out. So that's why it diffuses. And the reason that it takes more time than we would expect is if we look at where bromine is on the periodic table, it's a heavier gas. And so heavier gases take longer to diffuse. So random motion of molecules is why gases diffuse. They want to move all over inside of the space that they can take up. And the bromine molecules are moving fast, but they collide with the air molecules, and because it's such a heavy gas, it's not able to travel as quickly. Okay. Another example of diffusion that you might be familiar with, before we do this one, is if I were to take a bottle of perfume and then spray it in the corner of the room, eventually over time, if you're standing in the opposite corner from me, you would be able to smell the perfume, and that's diffusion. Okay, so then the questions that we have, it says, which will diffuse faster, CH4 or XE? Oops. If we look on our periodic table, xenon is a pretty heavy gas. Carbon and hydrogen are higher up on our periodic table. They're lighter gases. So they should effuse faster than our heavier gas. And then it says, explain why a gas will diffuse faster in hot air than cold air. And this is because in hot air, where we have higher temperatures, we have more kinetic energy, so molecules are able to move faster and be able to diffuse faster. Excuse me. All right, and so that's the end of part 2. Those are all of our notes for the kinetic theory. Let me know if you have any questions.